So today what we're going to do is start talking about classes here. So and the way we'll do that is to start, by looking at the lab. I'm going to look at the lab problems and discuss the topic from that perspective. So here's exercise 1. And what we need to do is create a class. And I'll explain in a moment what that is. So if you have your computers with you now, I suggest you go and take a look at that problem statement. You know what? I don't need to. I'm just going to work locally. There's no need to keep logging in remotely all the time. So I'm just going to work here. And let's make a directory called lab 06. This is lab 6. All right. So let's read what the problem is here. Develop a class called number. And please notice right away that that's an uppercase N. That's a naming convention that we're going to follow in this class. It's a common naming convention. This identifier names something called a class, and class names by convention in our course here will start with an uppercase letter. So this class, whatever that is, called number, will represent something. It will represent an integer value. Okay? So classes are used in software to represent things that, typically when you talk about this initially, you use classes to represent things in the real world. Like you can have a class for car, or a class for a person, or a class for an account. And so usually classes represent these concepts, these things that we know about. And we say that they model, these classes model objects of interest or objects in the real world. And the class should have a constructor, whatever a class is. A class is something, it has a constructor. In other words, a class is actually a pattern. And it's used to construct objects. It's used to construct instances of data. And so the mechanism that's used in computer languages to construct instances of classes, we do is we define a constructor. It's the constructor that it's like a function. A constructor is, or maybe it is a function. It's a block of code that runs when a new instance of the class is created. And so what we're doing is we have a class that represents an integer value. So what we can do is, and the class is called number, what we can do is create many instances of number to represent different numbers. So I can create an instance and let it represent the number 3. I can create another instance and let it represent the number 77, for instance. Or so I can create any number of number instances. And if we were trying to, here we're trying to represent integers, which is a very simple kind of artificial, not exactly artificial. It's it's a simple sort of representation. You could have another class, maybe we would call it account, and that could represent one of, it would be used to, instances of the account class could be used to represent customers in your, say, your website. If you were selling something and you have registered customers, and then when you want to do something in code with a particular customer, you would create an instance of the account class. And then you can access data about that customer through that object, through that instance. Maybe you want to get the customer's phone number or the customer's email address, or you want to store the fact that the customer has just ordered, a new part, and it's currently being shipped. That information can be placed directly in that account class, or could be sort of represented in another class, but you can arrive at it through the account class. But I'm getting kind of off there. Let's come back to the problem we're working on. So we're going to define this class called number, and we're going to use that to create instances of data that represent different numbers. And let's take a look at what the test code looks like at this point. So we're including the IO stream. That's we're using C in and C out. That's the reason for that. We'll use the assert macro, so we need to include the CAssert header. And then look at this. We have a third header that we're including here. And notice the difference here. These headers have angle brackets, but this header, the name of this header is surrounded by quotes. That's because this header is a header that we're going to create. We're going to define that header. And these headers are part of the system. So these are system headers. And so we use angle brackets to designate a system header, something that comes with your development environment. This is provided with the compiler. For instance, the compiler provides these headers. When you install a compiler, you get these headers with it. But you don't get this header. This is a header we need to define, number.h. So let's create that header. It's called number.h. So in this header, we will have the definition of the number class. Let's take a look at what that looks like. There's a definition right there. We say that we have a class called number. And it contains, this class contains things which we're going to specify between these braces. I haven't put anything in there. That's because, but this I believe will compile. This is valid because the compiler generates a default constructor for us that we always need to have, and it also generates some other default things which are required. Let's take a look at this. Now this block of code right here, I'm going to comment that out. But I'm going to keep this last line down here. It says all tests passed. All right. This line is useful if you're in Visual Studio. We're not in there, so I'm going to take that out. So we have a main function. Remember what is main? When you see main, what do you think of? This is where execution starts in your program. It's called the entry point. So this is the entry point. And what do? Well, we skip over this business here, and we come right down to this line. We print this here. Let's see if that compiles. Looks good. Now this constructor right here, let's see, I want to show. Here we're defining an integer x. So we have the data type int followed by the variable name x. So it tells the compiler, please create an instance of an integer and let me access it through the name x. And here's another instance. So we have telling the compiler to allocate memory to store two different integers, one named x, the other named y. And we could do the same thing with this number class. Create a number called a. So this class, this number class that we're trying to understand, is actually a data type, and we use it just like what the data types that we've been using so far. So we have the data type name followed by the variable name. So we have a variable a, and it will be of type number. We have a variable b that will also be of type number. Let's check our understanding now and try to see if this compiles. Looks good. There it is. So these, let's see if I go a little more here. So let's look at the source code here. So let's just take a look at this first line in the test code. So this is a pre-supplied test code, and I want you to use this this file when you submit your work. This file should be just left as it is. Well, you could delete this last line. Actually, you don't need that. But I would like you to simply leave this file as is and use it as your test code. And your job is to create this number class here so that the test code runs correctly. So this is an example of test first software development. Write the test code first and then implement the functionality needed to make the test code run. All right, so here, this is a little different. We want to create an instance of the number class and give it the name 9. But we want to pass in some data into this instance. We're going to pass in the number 9. And we want that number class to store this information internally. How do we do that? I'm going to add this little word here called public. That means everything that I'm going to write now is accessible by all code in the program. And I'm going to say this number class takes an integer n, and when it gets that integer n, it's going to store it in a member variable, which I'll also call n. Now I've got a section in the class which is designated as private. That means code, general code in the program cannot access the information that I have in private. They can't access it directly by naming it. So we have this is called a constructor. You'll notice that the constructor is a function. You see the function, we've got a function name. There's an argument list. We have one argument in this particular one, and they can all have different numbers of arguments. Then there's a function body. I have that all in one line, but we could spread it out. This is equivalent. So we have this function, and when we call it, we pass in an integer, n, and that's what we're doing here. This is calling the number function, the constructor of the number class, and we're passing in this integer 9. This takes a little getting used to that, but this code right here, this creates a variable called 9 that points to an instance of the number class that was created by calling that number function and passing in 9. Now when this function runs, it takes the n that gets passed into it. We put that on the right-hand side of this assignment operation. This is an assignment. The thing that's on the right is stored into the thing that's named on the left. But what is the thing that's named on the left side of that assignment operation? That thing is another variable, a different variable, but by the same name. But it's a different variable. And I indicate that by preceding the variable with this, these characters. This arrow looks like an arrow. It's a hyphen and a greater than symbol. So this arrow n equals n. So take n that gets passed in here and assign it into the n that's defined as a part of this class, which is down here. It's this n. Let me show you an alternative to this. Let's suppose instead of calling this variable n, I would call the variable k. Okay? That means when user code, we say user code, when outside code invokes this number constructor and passes in a number, n in our particular example, when they pass in a number, our code in here can refer to or access that number through the name n. And we'll take what value gets passed into the number constructor, we take that value n, and assign it to the variable k. And k is defined here. K is what's called a member variable of the number class. So this, I think students tend to think this is easier to look at. Is that easier for you to look at? It's just not common. What I showed you originally is more typical. But I'll leave it like this for now. I'll leave it like this for now, so you can think of that. But these are essentially equivalent. All right. So now we have we have this constructor defined so that this line will compile. So this compiles. What happens if we expose one more line of test code? Let's see what's going on here. So we're calling assert, and when assert gets a true value, it doesn't do anything. When assert gets a false value, then it prints an error message and quits the program. So if you can read it actually. I assert that 9 is not prime. Right? 9 is not prime. 9 is divisible by 3. 9 is not prime. So, so this variable 9 is a variable. This name 9 represents data. It represents an instance of data. So data, if you think of data, is very general. Right? Data is general. Data could be a string. Data could be an integer. Data could be a double, a floating point value. It could be a true-false value. It could be a single bit. It could be 64 bits taken together. So data is a very general term. So it's too general here. So the data that we're talking about is data that adheres to the pattern that we're calling number, adheres to that format. Just like if we had an integer called x, int x, or x represents data, but that data isn't general data. It can't be a string. It can't be a floating point number. It has to be of a certain form. It has to be an integer. Just like that, 9, the variable 9, represents data, but not general data. It represents data that adheres to a certain format or organization. And that organization, that format, is what we define in that number class. Now, once we have this data stored in 9, that we can run operations relative to it. And one operation that we need to implement is this function. It's called isPrime. So we have this is called the dot notation. So we have this variable 9, and we want to invoke an operation that's defined for it. So the number class has an operation called isPrime. And an operation is another name for a function. It's a block of logic that operates, that runs, that executes. So this number class is a function called isPrime. And isPrime returns a Boolean value. So if 9 is prime, it'll return true. If 9 is not prime, then the isPrime function returns false. And we want to write that code so that isPrime returns false, because 9 is not prime. So we want isPrime to return false. If we just pass that result to assert, we'll get an error message in term-based. So we need to negate that return value. So 9 is not prime. So we're going to assert that 9 is not prime. All right. So we need to add a function called isPrime that returns a bool. And just for now, I'm just going to return false. So we'll be right sometimes, and we'll be wrong other times. I'm passing in false because I want the test code to run. So here in the test code, we're passing in 9. So isPrime always returns false. That means we negate it here, it becomes true, and the assert just quietly returns and does nothing. Let me see, I gotta check the instructions here. Look at this. Your solution to this exercise should contain the following 3 files. There's main.cpp, that's what we're doing right now. We've seen that. That has the test code. And it's the test code that's given above. It doesn't need to be modified. It's good to go the way it is. There's another file, number.h. We created that. It contains the number class declaration. The third file that you need to submit with this lab is number.cpp. And this file contains the implementation of the constructor and isPrime. Actually, that's wrong. It also contains this function is divisible by as well. I need to modify that. So I'm going to show you now what we're going to do is create a third file called number.cpp. We're going to put the implementation code into that file. This file is okay. I'm going to create another file called number.cpp. I'll do that by copying number.h. Now, number.cpp only contains implementation code. It doesn't contain the declaration of the class itself. And this is number.h. Number.h contains, well, in this case, there's some flexibility about how to do this. So I'm showing you the most common format. In this file, I have what's called the class declaration. It lists the functions, the public functions. You can have private functions as well. It lists the public elements, the public members, and the private members. Those are called members. You have member functions and member variables. The public member functions and variables are preceded by this identifier, public colon. The private member functions and member variables are preceded by this term here, private colon. So we have a private member variable, k, and we have 2 public member functions. The constructor, number that takes 1 argument, and another function called isPrime that returns a bool. And see, we don't have braces here. These are similar to forward declarations, which we talked about last time. We're just telling the compiler with this code here that the number class has a constructor that takes an int, and it has a function called isPrime that returns a bool, and it contains a variable called k, which is of type int. So we're telling the compiler the form that the number class takes, the outside appearance of the number class. Sometimes this is referred to as the interface. So this is in a file called number.h. That's the header file. And if you see up here, we're including the header file. Include number.h. So these are separate files. Now each file, each CPP file, is called a compilation unit. And the compiler, we need to give the compiler a list of the compilation units. Normally a program doesn't fit in a single file. The program is spread across many files. And the files that are meant to be processed as individual units by the compiler, those are called compilation units. Now, in this file here, this is number.cpp. And in number.cpp, we need to include number.h. You know, I'm going to go back to this form. This is the form that I want. I think that I'm going to have to stick to this format. Pass in an n, huh? What's that? Two what? This is number.cpp, and this is the companion file that goes with number.h. And I'm gonna revert back to this form here. What's that?
So there's three then. You know?
There's three files. Okay. I'm going to show you again. These are the three files. Here's the entry point. This is the compilation unit, the CPP file that has the main function. That's where execution starts. And that's where we have the pre-supplied test code. And then we have number.h, which is the form, which is the outward appearance of this number class minus its internal functionality. The details of how the functions work. This file here, number.cpp, that contains the function definitions. And this is the common organization. There's other organizations possible. It's just this is the standard one. I'm showing you the standard approach. So I have three screens open. I can toggle through them here. This is main.cpp. It's the entry point and the test code. And main needs to be aware of the number class, so we include the number header here. This is number.cpp. Number.cpp, just like main, number.cpp needs to include a number header here. Because this has got the declaration of the number class in it. So the compiler needs to know that too, in order to correctly compile these function definitions. And finally, here's the third class. This is number.h. This has got the class declaration. We said we have a class called number. It has two public member variables, a constructor. You know this is a constructor because it doesn't have a return value. It has the same name as the class itself. Those are requirements for a constructor in C++. Other languages would have different requirements. And it has a function is prime that returns a bool. Once again, we're not saying how these functions run. We're not providing the code. We're just saying they're there. They exist. They're defined somewhere else. Well, they're defined in number.cpp. And then we have data that we're storing internally. And by convention, normally we keep the data private, normally. And so we designate that with this word private followed by a colon. So I have an integer n. Now these two n's here have different scope, so they represent different variables. It's like my name is David. And you know, there's a lot of Davids in the world. It's the same name, but they don't, the name David doesn't name a single person. It's used by different people. Just like that, this name N means something here. And the name N here means something else. They have different scope. The scope of this variable N here is just the code that's inside the number constructor, in between the code that appears in between the opening and closing braces. And this N here, its scope, is visible to all member functions. But if any function has an N defined within it, you know, it's the more narrowly scoped N, the one that appears in the function, that overshadows the member function N. I mean the member variable N. I'll talk more about that in a moment. All right, so one more thing we have to do here. That this function, it looks like what's called a global function. But we need to tell the compiler, no, this is not a global function. This is a function that's a member of the number class. So we use that syntax right there to do that. Is prime is a function. It's not a global function. It doesn't just exist everywhere. It's only to be thought of or used as a part or a member of the number class. So we precede the name is prime with number : : It's a little tricky. You don't precede the whole line with that. So the bool is the return type. Bool is a name that has global scope. It's just everywhere bool means bool. But we don't want everywhere is prime to be this function. We only want is prime, the name is prime, to be defined here, the way we're defining it, relative to this number class. Making sure everything is saved here. Look at this. We have 4 objects. It goes to the a.out, right? That's there. Let's generate. Now, when we run the compiler, we have to give it all the compilation units, like that. There's 2 compilation units. Main.cpp and number.cpp. The compiler goes through 2 stages of analysis when it goes to, not analysis, but analysis and output. It passes through, in a simplified way to think about it, passes through 2 stages. The first thing, it takes the individual compilation units and produces machine instructions that express the logic and data creation that is happening in those compilation units. And it generates 2, in this case it'll generate 2 what are called object files. One for main.cpp, another for number.cpp. Then in the second step, it links the 2 together. It combines the 2 together. That's called linking. Now sometimes you'll see, when you see error messages, you'll see a compilation error, syntax error. Syntax error. That means the compiler can't deal with that individual compilation unit. Can't figure out what you want. Then other types of errors occur after the compilation units have been processed, but now the compiler or the linker is running and trying to merge them together into a single executable. And if it can't do the merge, then you get what's called a linkage error. So it works. Now, if we just, let's suppose we just did what we normally do, which is just give main.cpp. We indicate one compilation unit, but not the other one. This will be You think this is going to be a compilation error or a linkage error? I know it's very advanced and everybody is totally confused. You know, I know that you're totally confused. And but this is kind of an abstract concept that about object-oriented programming combined with just programming in general and what is compilation and linking. It's all so difficult and new to understand. But if you just stick with it and read and experiment, and I'll keep repeating ideas over and over again and try to point them out as I encounter them, that it will eventually become clear to you. And this is a very useful information. This is not C++. This is computer programming. This is how to make machines do things for you. The same concept works in practically every language, these same concepts. So I'm going to hypothesize that this will result in a linkage error, because there's no syntax error in main.cpp. So the compiler will generate the object file without any error. But then, when it goes to the next stage, which is where it tries to resolve what are called external references, that object file will contain references to functions that should be defined elsewhere in other object files. In particular, this is prime function. Well, let me go. It's in main. We're compiling this. First, it's going to say, all right, I trusted you. You gave me the header file, so I know the form of this function, of this class number. So I will generate code that invokes a constructor. I don't have the constructor definition. I'll link against it later on when I do linking. Same with is prime. You told me in the number header that is prime is a function that returns a bool. I trust you. And I'll generate machine instructions that invoke a function called is prime. Well, I don't know where the function is yet. I'll let the linker do that for me. Because when the linker runs, it's going to say, where's is prime? Where's number? Where's the number constructor? I can't find it. So that'll be the linkage error. So let's see what that looks like. This is what it looks like. Undefined symbols for architecture 86. Number int. Reference from main in. This is a temporary file that gets created. See this .o? That's an extension. This is the file name. The extension is O, which represents object file or object code. It's the unlinked machine instructions. So main.cpp generated this. And it's saying that, hey, in this file, it's trying to, I need to find out where the logic is for the number constructor. And also down here, I need to find the logic for the isPrime function. So that's not provided, that's missing. So these symbols, this symbol here and this symbol here, are undefined. You see, LD on Macintosh and Linux, LD is the name of the linker for C++. So it's a linking the function LD is reporting this this error. Symbols not found. LD is a command. See, LD is the linker. So we can run the linker separately from the compiler. Now if we do something like this, I think, well, I haven't done this in a while. I think that says just compile, don't link. That works. See main.o. So it generated main.o. So normally we just skip that step. We don't do the compilation and then followed by linking. We just do it. We omit this -c. This is an argument that tells the compiler just compile, don't link. That's what that says. let's get rid of that. So the point I'm trying to make here is that, that you need to specify all the compilation units at the same time if you're going to use this kind of shortcut version to compiling and linking your code. All right. Now here's another function. Is divisible by 1. And so this number class has another function, is divisible by 1. It takes, is divisible by, and it should take an integer. And it returns true if the integer passed into it evenly divides into the number that the object represents. So is divisible by. Let's take a look at what happens if I try to compile that. Class error in main. Class number has no member named is divisible by. Let's add that. Is divisible by returns a bool. And it takes an integer. We'll say k. Oh, I spelled it wrong. Thank you. Is divisible. What's going on here? We added a declaration for is divisible by, and the compiler took it, but this LD here is complaining, is saying undefined symbol. So we named the symbol, we named is divisible by, we said there is a function, but we lied because we never provided an implementation. So we declare it here, we declare it, but we do not define it, we do not implement it. So let's go ahead and implement that. That's done here. Let's return true. Anybody see a problem here? There's a problem. There's a mistake. What's my mistake? I know you've got to be totally lost. I know that. Not totally lost, hopefully. Just a little bit of understanding there. Yeah. Braces? No, it's not the mistake. Huh? Good, yeah. Right. So this function is declared in global scope. But we want to say, no, this function is a member of the number class. Very good. So that's something that you'll have to deal with, that you'll probably forget. Okay, that builds, that runs. There we go. Of course, we have look at this. Is prime always returns false. Is divisible by always returns true. So these are called stubs. We got to fill the details in later. Well, we're getting pretty close to needing to do it. All of the rest of this I'm going to expose. So here we'll get an assertion failure. Let's see where. Is prime always returns false, so this will succeed. Is divisible by always returns true. Oh, so we'll fail right here. 9 is not divisible by 2. But we're returning true always. So we're going to return true, negate that, assert we'll get a false. So we're going to get an assertion failure at this line. There it is. Assertion failed is divisible by 2. So now we've got to get busy and to implement these things. How do we, if you know, we're a number, okay? So that's what this is called. This class number represents a number. It doesn't represent the k here. This is the k. This is the value that's getting passed in to this function. But this number class represents a number that is stored internally using this name n. So in the functions, we can use n. That's a member variable. So if n mod k is 0, then n is divisible by k, and will return true. This one too many. Else, will return false. Yeah? It's on the web page. I don't know. It's not tonight, though. Wednesday. This is due on Wednesday. So, you think that's not enough time, right?
You know what? Because like the whole classes thing, like it requires you to like go through the whole chapter 5.
Yeah.
You know, to understand it.
Well, maybe we'll move it back a little bit. Let's see how we feel on Wednesday. I'll take a vote. I'll take a vote on Wednesday. Anybody want to make a bet on how that vote is going to go? All right, anyway, here's is divisible by. Yeah, I know this is really tough, but I'll tell you, it's very valuable to get this. You know, I'm doing my best here to try to convey what's going on. But you're going to need to put time into this, and you need to experiment. You need to read, and you also need to talk. You need to talk about it. You know, a lot of times, I don't know, for me, it might be different for you, but if I engage in discussion over things with others, and I help to develop an understanding that way. You know, a slow understanding, yeah.
And audio learning?
I'm an audio learner. I am an audio learner. Anyway, so, huh? All right, so let's see. This is a complete implementation of is divisible by.
You messed up on one of your races.
Thank you.
The first one before
Thank you very much. It's still likely to fail. Oh, it worked. Okay. Oh, is prime. So is divisible by is working correctly. So we just need to do is prime. Let's get that done. So is prime. So we need to implement is prime. Let's do it quickly. We want to try every value. We have an n. We'll try to divide n by every value between 2 and n minus 1. If we find a number that divides into it and is not prime. Remember, this n is the internally stored n, the member variable n. So if we find a number that divides into it, we return false. If we don't find it, if we finish the loop here, we try every number, and we didn't find one that divided into it, that must be prime. We return true. So this is the third time we've needed to write out this algorithm. So you should have this, right? I don't want you to, maybe on a quiz or on the final, ask for this. Because this, I've given you a lot of chances to work through this and to understand what this is and how this works. Once again, it's not the most efficient way to check primeness, but that's what we have. It works. We got it done. Now at this point, you need to commit three files into the repository. Oh, one more thing. Include a UML class diagram with a multi-line comment. Let me show you what I want for that. Here's a multi-line comment. And here's what I would like for the UML diagram. It's a box that, looks like this. So in this, there's three sections. This is the UML class diagram. Unified modeling language. The name of the class goes here. That's the first section. You've got three sections. In the second section, we list the member variables. There's a member variable called n, and it's of type int. This is the standard notation. The variable name, followed by colon, followed by its data type. This section here is where you put the member functions. Oh, one other thing. The member variable is private, so we put a minus sign in front of it. And the member functions, we have three. We have a constructor. The constructor takes an argument of type int. And see, the reason to use n here is because it's simply going to be copied into our internal n here. That's the benefit and the reason for that naming convention. Number is public. And so we designate public with a plus sign. Yeah, I don't know, maybe it looks better like this, with spaces. I like the spaces. I'm going to put spaces in mine. And then we have two more public functions. We have one called isPrime. isPrime returns a bool, and it takes no arguments. And then we have isDivisible by. It takes one argument of type int, and it returns bool. This is the UML class diagram for the number class. And this is what I want for that part of the problem. So on a quiz, in the final, I'll ask you to draw the UML class diagram. Or I'll give you the UML class diagram and ask you to write out the class declaration. And then I'll also ask you to provide some implementation as well. So I'll show you. In the assignment, once again, the assignment looks a lot like the kind of problems that will appear on the quiz. That's that. Let me see if there's anything else really quickly. Any questions about this? Just 3 files. You need to commit 3 files in the repository. Make sure that your header file has the UML class diagram in it. All right, that's it then.